Good morning, good morning, good morning. This is your Captain Shreyas and welcome back, guys. Yes, it's 6 o'clock and your Vedantu English team is here for you, pushing you because we can take this as a recorded class, but no, we want to wake up for you and conduct this class live. I want this to be your habit. I want this to be your routine. I want you to be consistent because over time, consistency, your hard work, is going to win over intelligence. So, my dear students, make sure you're attending every single class live, and it's time to do the CYQs, the current year questions, with me, your Captain Shreyas Sir, of Newton's laws and friction. Okay, so I hope I'm audible and visible to all of you. Good morning. Good morning. Hi, Magesh, the devil only bike, Sabrinathan, Ibu, JEE aspirant Thala, future NITN, Zigro, Stone, Creep, my goodness. Man, please choose some short names. Kalai Senthil Murugan. Kalai Senthil Murugan. Okay, great. Steady Bud. Wow. Ridan, welcome, welcome, welcome. BD Harni. Hi, Alika. Welcome. Good morning. Good morning. Nice to see all of you. Have you done your mandatory thing? Or do I need to constantly tell you? Yeah, like the video. You have to mark your attendance, man. One thing you cannot do for Shreyas Sir waking up in the morning for you. Till yesterday night, I was in the Sigma crash batch. Yeah. And then 10, 10, 15. And then after that, you know, barely we get time to sleep. And today evening, again, there is a marathon, 6 o'clock for alternating current. So, guys, when in exam mode, even your teachers are preparing much more than you. So, you should definitely smash the like button and subscribe to the Vedantu J English channel. Okay. So, today there is a marathon evening. Do not forget. Let's begin with the class. And yes, the PDF will be available in the description box after the video ends. Here's the first question on your screen. A spring balance is connected to two masses as shown. The reading shown is how much? Interesting. 20 kg here, 20 kg here. This is a massless string. This is a ideal weighing machine or sorry, spring balance which has negligible mass. So the question is, what is the reading shown in over here? Will it show 0? Will it show 10, which is half of them? Or will it show double of them, which is 40? Or will it still show 20? That's the question. Answer it in the chat box right away, right now. Okay. Oh, today you are in NITs. Who is it? Saksha, Saksham, Saksham Dengre. Oh, nice. Thank you so much, Saksham. I'm so glad that you are in NIT today and you are once a part of Vedantu J English channel and you have come. The more interesting part is you have come in the morning, 6 o'clock to tell this. This is hats off. Kudos to you. Kudos, man. Thank you so much. Means a lot. All right, 40, 0. So this is a common mistake which many kids do. And I'll tell you what. See, when I tell that there is a spring balance, okay, and you have connected example 20 kilos mass. What reading does it show? What is the reading that it shows? It will show 20 kg reading. Now, when I say it shows 20 kg reading, it is being pulled by 20 kg force. But do not forget, it is also supported on the top by the roof. So, strictly speaking, there is a 20 kg force down, and the roof also applies a 20 kg force up. This force, if I call it as the pulling force, only pulling force can't exist. There must be a supporting force, or else it is going to fly off and fall off. Now take this diagram and rotate it like this. You'll realize there is a 20 kg force here and there is also 20 kg force here. So always the forces are there on both sides and equal, and then it is balanced. So it shows one of these forces, either the pulling or the supporting force. So it is never double and never does it cancel out. I mean, yes, the net force is 0. Always the net force will be 0. If somebody is hanging on the spring balance, downward force will be balanced by the roof force. So the force net wise will be 0, but it is always one of the forces which is being pulling it is measured or shown on the weighing scale. So hence the answer will be 20 kg, D option. Got it? How many of you made this mistake? Pakka negative 1 marks you would have got in the JEE Mains examination now. All right. Good morning, Vara. Yeah. Today is the end sem. Oh, end sem paper. End paper means I understand. NIT, IIT bits. People don't sleep, or they will wake up early. Suddenly, engineering wing only, hostel wing, you will see whole night the light is on because one person is sleeping late at 4 o'clock. One person is waking up early at 3 o'clock. So, that is a funny thing. End sem. Yeah, good. All the best, man. So, the block of mass 10 kg rests on a rough inclined plane making an angle of 30 degrees. The coefficient of friction is 0.7, the frictional force on the block. It seems like a very simple question, but it is not a simple question. You will realize after solving it. So, over here, we have that inclined plane and we have that particular block. Okay, like this. And it is on that inclined plane. Now, what are the different forces acting on that particular inclined block? So, first is obviously it's mg sine theta. I mean, you split up mg into two components, mg cos theta, then there is normal also, and then there is friction. These are the only forces acting on it. So, you have normal and mass is 10, right? So, 10 g and then cos 30. Then you also have 10 g sine 30 and then frictional force will be over here. Now, if you see the math, you will see that normal force will be 10 g cos 30. Cos 30 is root 3 by 2, right? So, it will become 5 root 3 g. That is the normal force. 5 root 3. 10 into root 3 by 2. 2 and 10 cancels, becomes 5. Root 3 remains. So, 5 root 3 g. Now, if you see the downward force, the downward force, the downward force, the downward force is 10g sine 30, which is sine 30 is half, so it will basically become 5 times of g. Now let's think what is the maximum frictional force which is possible, which is mu into n. Mu is 0.7 as per this given data. Normal force is 5 root 3 multiplied by g. Now root 3 value is 1.7 and this into 0.7 into g. Is that right, guys? Is that right, guys? Everybody with me? Pakka till this point. Now, what is the catch in this problem? Why did Shreyas Sir take out the value of Fs max separately? Couldn't I just say the frictional force is actually Fs max? What is the problem, guys, in this? Come on, quickly think and tell me. Quickly think and tell me. Okay. Oh, by the way, we'll just complete this. 17 sevens are 119. So this will become 5 multiplied by 1.19 G. Okay. Why I found out Fs max is because I can see that my downward force is 5G. The Fs max is 5 into 1.19 G, meaning downward force is less, Fs max is more. So the downward force, the downward force along the incline is less than the limiting friction. So my friction, it has no longer reached its limiting value, or the inclination is not so much that it has crossed the limiting value. So the downward force, if it is less than Fs max, it means this frictional force will be exactly just balancing 10g sine theta, will be equal to that downward force, and hence the downward force, if it is 5g, it will remain 5g. So 5g means 50 newtons. 50 newtons. That is the answer. Okay, so option A is the correct one. If by chance, let's say this came out 5 into 0.99 G or 5 into 0.86 G, then what will your answer be? Then what will your answer be? Then your answer will be the actual Fs max, that is mu mg cos theta, which is mu m. Okay, then this will be the answer. Okay, because then our downward force is more and the Fs max is less. That means you have overcome the static friction So right now it is in sliding motion. So the friction which will be acting is mu into m. It will not be less than v. Got it? Everyone with me on this? Absolutely clear? Pakka? All right. Let's go to the next question coming up on your screen. There is a conveyor belt on which you are pouring sand at a constant rate. The force necessary to keep that belt moving is how much? So say for example, this is our conveyor belt and this conveyor belt is moving at a constant speed of v. Okay, and then you're pouring in sand on it, and as sand particles will fall, they will start moving with that same velocity on that belt. So right now just think a dm mass falls onto it and acquires that velocity in no time. In time, in time dt, it will acquire that velocity. Right now it was at rest. So this is what is happening. So because a mass falling onto it accelerates to acquire that velocity, so you are changing its momentum. So the only force needed is that initial acceleration which is needed for that every particle of that sand. Once it has acquired that speed, you don't need any change of momentum, you don't need any new force. So the force is only needed in the starting part, guys. So the force is only needed only in that starting part, and that particular force is nothing but the change in momentum divided by the time which is required. The change in momentum, well, the mass is dm, the final velocity is v, minus 0 because initially it was at rest, divided by dt. So it will just become dm divided by dt multiplied by v. But dm by dt is the mass per unit time which is given already, which is m. So m into v. So the force which you need to keep it moving is nothing but mv newtons, which is D option. It can't be 0. 0 is only for that part which is already in motion. So this which is already moving, already moving, already moving at that constant speed v, no force is needed over there. No force is needed. And why do we don't need any force? Because momentum is constant. Because momentum is not changing. Only when momentum changes, force is needed. Momentum is constant for that particular part. Only that initially we need it to make sure that the grain which falls, it accelerates and goes along with the belt and acquires that final velocity of v. Is that understood where you need it and why you need it? Perfecto, Ridan, Nagulan. Okay, Mehran, good morning, good morning, good morning. Yes, BD Harni. Yes, Kirti, everyone. Sabrinathan, Indumati. All right, smiling Grassy. Okay, perfecto. Let's go to the next question on your screen, and here it comes. There is a kid who is standing in a weighing machine in a lift. Why the kid is doing all this activity, don't ask. That too in the morning, we are thinking of a kid, imagining in a weighing machine in a lift. Some students even dream of it. All right, when the lift is going down, then the machine soars 20 Newton. When the lift goes up, acceleration g by 3, the reading will be how much? Going down this much, going up how much? Interesting. So when you are going down, right? When you are going down, the effective acceleration is always negative. So it is g minus a. So the apparent weight that you will notice, the apparent weight that you will notice will be the mass of the kid into the perceived or the effective gravity which you are seeing inside that lift, which is basically going down. So the apparent weight is clearly mentioned as 20 Newton. Mass, I do not know, but G effective will be 10 minus what is, or basically I can just say it is G minus G divided by 3. So G minus G divided by 3 means 2G by 3. So M multiplied by 2G divided by 3. So take it on the other side. So I will get M is equal to 3 multiplied by 20 divided by 2g. which is 2 cancels, so it will become 30 divided by g. So that is the value of the mass which I calculated from the first information. Now when the lift is going upwards, then the effective gravity will become g plus a. It will become g plus a. So the new apparent weight will be mass into the total gravity, which is the effective gravity. Mass I know already is 30 divided by g. G plus a will become g plus g by 3. So that will become 30 by g. G plus g by 3 is 4g divided by 3. G cancels. 30 and 3 cancels. It will become 10 and multiplied by 4. So it will become basically 40 Newton. So 40 Newton is option A, of course. Yeah. No, it is not D. It is option A. Yes, Captain Ibu, correct. Yeah, study bud. I think you made a mistake. All right. Option A, option A, option A. See if you have made any mistake. Going down negative, keep that in mind. Going up positive. So what is this G effective? It is the total gravity which you will see or feel or perceive inside a accelerated lift which is going up or down. Okay, so you can solve the problem normally like you would do on earth, whether it is projectile problem, free fall motion, a block on an incline, pulley problem, spring problem, whatever. But instead of putting G, you have put G effective. This G effective comes because of the pseudo force. Okay, so that is the concept of pseudo force which you should be aware of. Next question on your screen, here it is. Two blocks are holding another block, negligible string, negligible pulley mass. Okay, what is the angle theta for them to remain in equilibrium? Straightforward. Equilibrium is needed. So, my dear students, first of all, as you can see over here, the system should experience no net force. So you can take any mass, like for example, over here, this particular mass will be balanced by a tension over here. So whatever is this particular mg, that same tension should go over here, and tension will be value wise equal to mg because it is at rest. Now, that same tension will go like this and it will be here. The same mass is on the other side. So, by symmetry, same tension should be here also. So, one can say T is here and T is also over here. And do not forget that this mass will also have its own weight, and that own weight will be root 2 times of m multiplied by g. I feel that these are the only forces which are there on the system, nothing else is there. So if you consider the root 2m mass, the tension will have vertical components and horizontal components. It kind of becomes obvious to see that the horizontal components are going to be opposite and equal, so they will anyways cancel out. It is the vertical components for this particular tension and for this particular tension which will add up in the vertically up direction, which will be balanced by the downward force. So I can just say tensions cos theta. Why cos? Because this tension, if it is there like this, the closer, C for cos, C for close, the closer will be cos. The far away, the red one will be sine component. So the closer cos component, T cos theta. But there are two such things, will be balanced by the downward force of root 2 times of mg. But what is this tension? It is small mg. So small mg cos theta multiplied by 2 is root of 2 into capital mg. Gg will cancel. Gg will cancel. And is that mentioned? How much is capital M? Oh, it is same as small m only. So everything is same. So this is same. G is also going to be same. So how much is cos theta going to be? It will be root 2 divided by 2, which is 1 by root 2. So that's it. Cos theta is 1 by root 2. So it will be cos inverse of 1 by root 2, which is, I know it is 45 degrees, but yeah, we can just leave it like that because the options are like that. Okay. Yeah, it is 45 degree, but you have to leave it in the given or required form. Don't try to put 45 degree because that is not there in the options. Is that okay? Perfect. Can we go ahead? Okay, let's move. This question, graph-based question also, guys. Graph-based questions can also come. Speed versus time graph is given, and this is the speed of a lift in which passengers are there. The passengers with the lift is 1000 kilos. The variation of the speed of the lift is given. the tension in the rope pulling the lift at 10.5 seconds will be how much? Interesting question. So let's think about the lift first. How will it look like? This is our lift. It has some passengers inside. The lift is being pulled up. So what happens is you will see there is some kind of tension. The lift along with its passengers will have its own weight. I will call it M into G, and the lift is going to accelerate upwards. So I'll put some acceleration like this. But here is the catch. A lot of people will make this mistake. See, here the speed was increasing, constant and then decreasing. So if you are asking me at 10 point, what is it? 5 seconds, which is somewhere over here, 10.5 seconds, which is over here. Okay. I have a feeling that the acceleration is negative. And when I say negative, it means it is actually downwards. Speed is reducing. The lift is going up and reducing the speed. So the catch of the problem is exactly over here. Many kids show the acceleration up. They forget that the speed is reducing here. So technically speaking, the acceleration is downwards. Which means if I apply Newton's law, I will see mg minus t is equal to ma. Therefore, t will be mg minus ma. So it is m into g minus a. Lot of students will write t minus mg because they feel acceleration is up. Did you understand the crux, the catch, the trap which is there in the problem? Isn't it amazing, guys? So many kids are going to make that mistake. So you be careful. Okay, just don't assume things. You have to see the graph is reducing, so it is decelerating. Decelerating means negative acceleration. So the direction where the vector will be downwards. But that's not over yet. There is one more problem. How much is the acceleration? So for that, look over here. So if you want to measure the acceleration, check out magnitude wise. I'm saying magnitude wise. Just check out the magnitude of the slope, and the magnitude of the slope is height by base. So height is basically how much? 3.6, and the base is nothing but 2, so it will be nothing but 1.8 meters per second square. Yeah, the y change divided by the x change, that is going to be the slope. Now you just have to substitute it. How much is the mass? It was 1000 kilos. G is 10 minus 1.8. Is that right? So it will become 1000 multiplied by 10 minus 1 uh, 1.8. Yes, 10 minus 1.8, which is going to be 8.8, which is going to be 8,800 Newton. That's what it is going to be. I think the options are not matching, but yeah, it should be 8,800. I think this 8 should have been there. Yeah. Yes. Is that absolutely clear, my dear warriors? This is very important. First of all, the slope you need to calculate it. This is 3.6, this is 2. So height by base. So that's going to give me how much? Height by base 3.6 divided by 2, which is 1.8 meters per second square. So the tension in that rope will not be mg. A lot of people make that mistake. It is not just mg. It is m into g minus a. So 10 minus 1.8. Oh, sorry, why did I put 8.8? Guys, I'm in the morning. I think sometimes I make these things. 8.2. So sorry, guys, 8.2. So this will be 8,200 Newton. So sorry, 8,200 Newton. So this should be 8,200 Newton. So this will be the most appropriate answer. Okay, closest answer this will be 8,000. Yes, it is 8,000 Newton. But really speaking, the 200 should also have been there because it's not such a big deal to put 2,000 over here instead of just 8,000. Anyways, let's go to the next question on your screen. A block of mass m kg is at rest on a rough horizontal surface as shown. It's at rest on a rough horizontal surface as shown. Friction coefficient is mu. A force which is acting is mg at an angle with the vertical pulls it. The block will be pulled when? What condition should be met? Very nice question. Let's do this. Let's do this. In the previous question, if you take G as 9.8, Yeah, maybe you will get it, but I don't think they have mentioned G as 9.8 anywhere. So yeah, so only then you can get it. So over here, I have substituted the value of G as 10. I've substituted the value of G as 10. But if you substitute it as 9.8, 9.8 minus 1.8, then it will be 8,000. Then otherwise, you will get it as 8,200. Okay. So usually when they don't specify, remember we use G as 10. But if they specify it, then you have to use whatever they have given. So it's better that they give the value, or else we are used to taking GS 10. Anyways, coming back over here. So first let's draw the free body diagram of this particular figure. So our block is here. What are the different forces acting on it? There is one normal force, there is mg force, then frictional force will prevent it from slipping like this. So there is friction, there is normal reaction, and then there is its own weight, and the external force which is there, it is acting like this at some angle. Oh, it is this side. So technically our friction should have been here, then our friction will be over here. Okay, so our external force is like this. Our external force is like this, making an angle of theta, So the force will have two components now. One component will be like this, and the other component will be like this. So this component will be F cos theta, and this component will be F sin theta. These are the only forces acting on the system. Is that right? So now let's start doing it. If you look at the vertical direction, my normal reaction, plus my F cos theta will be balancing mg. So therefore, my normal reaction will be mg minus F cos theta, but the value of the force is given to be mg. So it will become mg minus mg cos theta. So I can take mg common, and it will look like 1 minus cos theta is my normal reaction from the ground. That is the first thing which I got from the vertical direction. I need this because I realize whenever forces outside are at an angle, the normal reaction will no longer be mg. So I need to recalculate how much that normal is, and don't take any shortcuts. Just try it normally, you will get it. Next thing, if I go in the horizontal direction, if it has to be pulled, if it has to be, if it can be pulled, then my external force should be more than the friction. So I can just say my external force, which is F sine theta, has to be more than the friction's limiting value, F max. Now, what is F max? Basically, what is F max, guys? Think about it. F max is mu multiplied by normal reaction. Now, I think I know already what the normal reaction is. Good thing I calculated it here. So mu is there, mg is there, and it is 1 minus cos of theta. Rest force is nothing but mg over here, and that is sine of theta. Now, one thing good is happening, at least this mg and this mg is going off. Great, but I'm not done yet. I have sine on one side, cos on other side, and I need tan or cot. So what do I do? So well, first of all, sine theta will be more than or equal to mu into 1 minus cos theta. Try and recollect what is 1 minus cos theta. Try and recollect what is 1 minus cos theta, cos double angle formula, guys, if you have forgotten. Okay, some of you have forgotten. So let me remind you, cos 2 theta is nothing but 2 cos square theta minus 1, or 1 minus 2 sine square theta. So therefore 2 sine square theta will be 1 minus cos 2 theta. If you use a half of the angle, then it will look like 1 minus cos theta if I had instead of 2 theta. Then this will be 2 into sine theta by 2 square. Sine square theta by 2. So instead of theta, theta by 2. Instead of 2 theta, theta. This will be the formula. So 1 minus cos theta is 2, is nothing but 2 times of sine square theta by 2. Okay. And sine theta also, now I have an idea. Let's write it like this. Double angle formula. 2 sine theta by 2 into cos theta by 2. Remember, sine 2 sine is cos A is nothing but sine 2A. Sine of a double angle is 2 sine A cos A. So same formula I have used. So what happens? Sine theta by 2 and 2 will cancel on both sides. I am left out with cos of theta by 2 is more than or equal to mu times of sine of theta by 2. Take sine below. So you will have cos theta by 2 divided by sine theta by 2 is more than or equal to mu. Cos by sine is cot. So it will become cot of theta by 2 is more than or equal to mu. So which is obviously D option. So that's why I said it's a brilliant question, because yes, there is a lot of maths involved, manipulations, and free body diagram right from the basics and the physics condition that the external force should be more than the limiting friction. Only then it can slide. Yeah? Everybody loved this? Okay. Study well. Yes. Exams. Bagar IP. Oh, IP is there. It is there. IP will come and go. PU will come and go. Board exam will come and go. JEE exam will not just come and go. JEE is only one time. And if you are thinking it will come, sir, it will come in April also, no? April, it will come like a flying visitor. Cameo appearance, it will come. Hello and tata and bye bye. That's it. Like one heroine will come, no? Like that. So many movies are there. Some heroine will come or hero will come. Cameo appearance. Like that only it is. Yeah. So be very careful. Okay. So focus on J exam. This is what many kids make a mistake. Especially I've seen in Andhra and Telangana, because you are, I don't know, schools and colleges. I have counseled so many parents and make sure that they do not enroll their kids into long school hours or long college hours. 7 o'clock, 8 o'clock to evening 5 o'clock, 6 o'clock. What can you teach? So much. There is nothing to teach. Even if you keep reading NCERT and all the textbooks, it will get over. There is nothing to teach so much. You have to enjoy, you have to play, you have to develop your personality also. And you need time for self-study more. So, make sure that you do not fall with the sheep, or else you will go with the sheep. If you are thinking like everyone, you will also go with everyone. If you think differently, you will be different and you will reach the top. So, let's see what's the next question on your screen, and here it is. A block of certain mass and is kept on another block and is tied to a wall as shown. The coefficient of friction between A and B is 0.2 and that between B and the ground is 0.3. The minimum force required to pull them is how much? Okay. Okay, let's see. How do we do this? First of all, let us draw the FBD of the topper block. Topper block, no, top block. This is top block. Okay, what are the forces, guys, on the topper block? First is its own weight will be there. What is its mass? Block A, 100 kilos. My goodness, 100 G down. Then there will be a normal reaction on it. And then there will be tension force on it. Okay. And because the block B is pulling it, so it will experience that indirect pull via the friction which is acting on A. So I'll call it FA. Now, if you draw the free body diagram, similarly, of our block B, of that particular block B, here are the forces acting on it. First, the upper block's weight will indirectly act. This normal force will be obviously 100 G. So that same normal force will act down, which will still be 100 G. This block has its own weight, which is how much? 200 G. Somebody is pulling it externally, so F. If this friction is acting on A will apply a force on B in the opposite direction. So whenever you have block and block problems, Newton's third law comes into play. So equal and opposite forces. By the way, this FA will be mu into N. And what is that mu? Mu between A and B is 0.2. So this will be 0.2 multiplied by normal, which is 100 G, which is 20 G indirectly. So this friction will act, which is basically 20 G. Is that okay, everyone? So between A and B, the coefficient is 0.2. The normal force that you will consider, which will be between these two surfaces. This is action, this is reaction. This is action, this is reaction. How do I know FA is forward? Because if block B is below and you are pulling it, so block A's bottom surface will be scratched like this. Visualize, block below is pulling it, so it will scratch it like this. So force will be this way. So if B applies on A right side, A applies on B left side, action, reaction are equal and opposite. Last thing is the ground surface will also experience friction because B, if it is going forward, so there will be a friction like this, FB. And before that, we also need a normal force over here, and that will be NB. And how much will this normal be? 200 and 100 together. So 200G plus 100G, which is 300G. And this friction will be mu B into the normal force. How much is the ground friction? 0.3. So this will be 0.3 multiplied by 300G. 3 3s are 9. So this will be basically 90G. So this is 90G here, FA is here, and this F is here. So from this, in the horizontal direction, my external force should be at least equal to the frictional force preventing it on the top and at the bottom. So it will be 20G plus 90G. 20G plus 90G is parallel G. No, it is not parallel G. It is 110G. Yeah. So guys, that is the answer. 110G. There you go. 110G means 1100 Newton. Everybody got it? Akka, let me know quickly in the chat box. Everyone, shall we go ahead to the next question coming up on your screen? Ready for it? Okay, here it comes. Wow, we have constrained motion. You are pulling this string over this pulley. This mass is going, making an angle theta. What is the velocity of the block? Whenever such questions come, always do supply demand, split the components, and you will see it becomes easy. What do I mean by that? See, this velocity is here. So this is pulling it. So there will be a demand of the string here like this. Whatever string goes here, same string should come here. So V string will go here. So this mass now, what will happen is it will start moving towards your right hand side. Let's say U. This is the actual velocity with which it will move, some other velocity. And this velocity will have two components. One component like this and the other component like this. If this is theta, then kind of obvious that even this angle will be theta. This will be 90 minus theta. What happens is this particular component is a useless component because anyways it is perpendicular. It's not doing anything, but it is this component which is useful for me because that u sine theta component is supplying that string over here, which is converting itself into v. So if u sine theta is v, u will be nothing but v divided by sine theta, which is option C. There you go. So it's all about supply demand. Demand is there, supply should be there. This block will actually move like this. So it will have two components, but this component is of no use. It is not giving any string. It's perpendicular. This component, whatever it is, will supply that. So u sine theta will be v. That's how you have to solve it. It's very straightforward. Yeah. Mehran, the classes are usually for 50 to 55 minutes, 45 minutes, maximum 1 hour. All right. Moving on to the next question. Last few questions, guys. On your screen, it is. Here it is. A rope of weight W hangs between two trees as shown, making angle theta with the horizontal at the ends, the tension in the center of the rope. Very nice question. Let's try to figure this out. It's like this. And this is theta. Okay, over here. And even this is given to be theta. And the question is, what is the tension at the center of that particular rope? So first things first, at this point, the tension will act obviously both ways. So you can't just draw the free body diagram of the rope. It is of no use because then the tension will be internal force. So you need to make it external. So what we'll do is we'll just consider we'll just consider only a part of the rope, half a part of the rope. Okay, so something like this. So this is exactly half part of that particular rope, like this. This is theta. Only consider half of that rope. Then what will happen at this point? That particular tension will become an external force. Right now over here, it will become internal force. But if you take only half of it, it will now become external force, and only external forces are counted. Now, at this particular point, you will see that there will be another tension. Let's say I call that as T1. The weight of the rope will also be there, but it is half that rope. So this will be nothing but W by 2. That's it. These are the only three forces acting on that rope. These are the only three forces which are acting on the rope. Now, if that angle is theta, it's quite obvious that even this particular angle opposite it will be theta. Okay. So, if I write in the vertical direction, T1's sine theta component, T1 sine theta, which is vertical, will be balanced by the W by 2, and T1's cos theta component will be balanced by this tension. A component here will be balanced by this, a component here will be balanced by this. That's it. So kind of obvious what should be the next step. You just have to divide both of them. So the moment you divide both of them, what are you going to get? T1 cancels. You are just going to get sine theta divided by cos theta is W by 2 divided by T. Sine by cos is nothing but tan theta is equal to W by 2 into T. But we want the value of tension. So tension, if you take it on the top, it will become W by 2 times of tan theta, which is W cot theta whole thing divided by 2. That is the value of the tension. W cot theta divided by 2. C option, absolutely correct. I think for the very first time you might be seeing, or you might have seen also, this particular question where you have a rope with mass. That means it is not ideal, and that too it is not straight, it is at an angle. So it's a very good question which talks how to solve questions on equilibrium and free body diagram. Yeah. I think I'm too late. I've started to watch your previous lecture. I have doubts. Yeah, maybe you can definitely, and you can keep watching the classes. And I'll tell you one more thing. We right now have Ved AI to help all of you guys, not just in the live class, but even after the class. So when you watch the lecture, right, and you are going down in the description, you are going to see take help from Ved and Ved AI, and all of it is there. Try Ved now. So you can use even Ved for YouTube lectures. You can ask doubts. Ved can also curate questions for you. So that's a fantastic part. So please check out Ved AI. Obviously, I am there for the more personalized mentor and your guide. But Ved AI, please use. You have to use AI till a limit. And beyond that, obviously, you will need your captain Shreyas Sir. Okay, cool. And my playlists, everything are there. Please check out the playlist on the channel. Yeah, the W by 2 will come from the center of mass. Yes, absolutely right. So this should be the center of mass of the half of that row. That's why I'm showing it over there. Yeah. Is that okay, Kamesh? Yep. Perfecto. Amazing. It's not B option, it is the D option. Some students forget to take the inverse of it. All right. Next question on your screen, and I think this is the last question. Two identical blocks M and M are attached to the massless string which passes over a pulley over a fixed axis as shown. An extra mass M is placed on the other block. The acceleration with which they will move together is actually the same old thing which has been again and again reframed into different ways. Think like this, as if this mass over here is M and this mass over here is M plus M. So heavier mass will go down, lighter mass will go up. That's it. And always A will be the big minus the small mass upon the total mass, whole thing multiplied by G. So the bigger mass is M plus M, smaller mass is just capital M, total mass is M plus M plus M multiplied by G. MM cancels, so it will become mg divided by 2 capital M plus small m. It's the same old thing, it's just asked differently. So this is the answer, option A. Got it? Perfect. Yeah, option A. I think you should get it within few seconds. Now I've kept couple of homework questions. This is the first homework question. A machine gun is firing some bullets at some speed and the force which is experiencing is so much. How many bullets are coming? Hint is use force is rate of change of momentum, but here it's not just one bullet. There are n bullets. So you take that momentum and multiply it n times. The bullet will be at rest initially and then it will be accelerated to finally acquire this velocity. So there is a change in momentum per unit time per bullet. So if you multiply it by n, which I have to find out, you will get the total change in momentum per unit time. From that, you can find the force. So I've given you the hint. Try and solve it. The answer will be there in the PDF. The PDF will be uploaded in the description box of this video. In the description box of this video only, you will see it. Okay. After some time, not now. Which one of the following person is an inertial frame of reference? This is your second homework question. Remember, inertial frames are those frames which do not accelerate, or basically they have no net force. The forces are balanced on that body. Okay, so that is inertial. Non-inertial is where Newton's laws are not valid. They are accelerated, like the lift frame or an accelerating car or a rotating frame. These are non-inertial frames, accelerated frames, where the net force is there. So answer is there on the next slide. I cannot show it. You can download the PDF and verify it, but your homework answers should be there down in the comment section. Okay, and thank you for liking and watching the video. If you have not yet liked, please like it right now. And you can see that students do solve the questions and put up the answers in the comment section. Okay, so make sure you are putting up the answers like this after the session is over, and make sure you are commenting also. Great. Thank you so much, guys. Have a great time. Bye bye. Captain Shreyas signing off.